Hello and welcome. In this video, we shall see how to draw the ray diagram of a simple microscope. Before moving on to the diagram, let us see the principle of simple microscope. It says that if an object is placed between the optical center and the focus of a convex lens, it produces a virtual, erect and enlarged image of the object on the same side of the lens. So here the placement of the object is important, which gives us a virtual, erect and magnified image. This is how a simple microscope works. The object needs to be placed between the optical center and the focus to get the virtual and magnified image. Let us see how to draw the ray diagram. Let us draw the lens, the principal axis. C is the optical center of the lens. Focus F is drawn. Let us place the object AB in front of the lens between the optical center and the focus. This placement is important. The incident ray which travels parallel to principal axis after refraction passes through the focus. We need to extend this ray in the backward direction. So we draw it by dotted line. The other ray which passes directly through the optical center goes undeviated. This ray also needs to be extended in the backward direction. Wherever the two rays meet, that gives the position of the image A', B'. So we see that the image A', B' is virtual, erect and magnified. A little more construction is required here. So we draw the straight line of the incident ray up to A', B' and we join that point with C. Let us call the point as P. So the direct line is drawn from P to the optical center. The importance of this is it gives us the angle alpha. So alpha is the angle subtended by the object at the eye. Beta is the angle subtended by the image at the eye. These two angles are important because magnifying power of the lens is defined as beta by alpha. So the two angles have their own significance. U is the object distance which is measured from the optical center. The focal length is marked and the image distance is marked. This image is formed at the least distance of distinct vision, which we denote as capital D. So this is the image formation in case of a convex lens for simple microscope. This is for the case when the image is formed at capital D, that is 25 centimeters. But the image can also form at infinity. That is another case where the image is formed at infinity. The difference is that the object AB is placed at the focus of the lens. So here in this diagram you see AB is placed at the focus and the incident ray parallel to principal axis bends, which we extend in the backward direction. The other incident light which passes through the optical center also is extended in the backward direction, but these two rays do not meet. We say that these two rays meet at infinity and thus the image is formed at infinity. So these are the two diagrams of convex lens working as a simple microscope. Thank you. For queries in physics, log on to www.rupaliday.com.